I have an M1 Mac Mini. Super happy with it. It goes faster than my octa-core Intel laptop. I'm shocked at how fast it goes.
Yeah.
Anyway, I upgraded to the latest.
Yeah. That's good to hear that. My wife got it. We haven't gotten it yet, but we ordered a 10 core Mac Pro 14 inch for her.
Nice.
She has like a 9-year-old laptop. So it's
There
going
was
to
a
be night
column in
and day.
there was a column in the New York Times yesterday about how great that processor is. I'm like, really? The New York Times is like having fanboy articles about CPUs? Okay.
Yeah.
I think it might be bleed over because I think there is a fanboy at New York Times on Apple. So anything to say anything good, I guess. But yeah. All right. Well, we're at 7, so we should probably stop chatting about laptops.
Right. And I see Ying Zhen's online. Ying Zhen's online too. She's been for a while, so we can just start.
Okay. Yeah.
Okay.
Yep.
Okay. Good morning, everyone. Buenos dias for those of you who are pining for Madrid. And happy Veterans Day. This is the note well. I know you've seen it a lot in the other ones. The crux of it is you need to comply with all these IETF rules, including declaration of any IPR you know about related to work in the IETF, and your attendance of the meeting constitutes participation. The other one people have asked to call out is the code of conduct. I don't think we've had too much problems with that out of our working group. We haven't had, but that's also we're obliged to treat everybody with respect. We have a few RFCs. The 9088 and 9089 are kind of germane to one that's being proposed later in the session, so that's interesting. These are just waiting on a decision on whether to wait for the BFD Yang Biz. That's RFC 9127. There's a long conversation going on in the Yang doctors, but they should publish, I would hope in the next couple months, even if we wait for the BFD Yang Biz, because it's a very short, very small change to the.
I don't know, AC. I'm not sure if we have anybody that's vision impaired, but that's what you were just talking about are the Yang data models for OSPF and the Yang data model for ISIS.
Oh, right. Okay, sorry. Yes, the
No,
Yang data models. The base models, the 100+ page documents on which all the other Yang documents are augmented. This one's pretty much done. The encoding, ISIS encodings for SRv6. We're waiting on Flex algorithm and a Spring document on OEM. I'm not going to say anything about, the only one I'm going to say something about is the Flex algorithm. We had some changes to that. We had an errata for the extended attributes, ISIS and OSPF drafts. That's 8920 and 8919, those RFCs. And now that it's finally through the second working group, last call, it's waiting on John to review. Chris, the reverse metric, is it still in IETF last call? That kind of completed without any.
I know, I think I got I think John might have sent me some review comments, so I filled them out, and I think we just pushed forward on that.
Okay, good.
Is that the case, John?
I sent you review comments. You took care of them. Then I went to IETF last call. The IETF last call is probably finished by now, but I have that on my list of things to check up on. But it's presumably, if the last call hadn't finished already, it'll be finished by the end of this week, and we can kick it on to the next step.
Great.
Okay, great. We got these two SR Yang models, OSPF SR and ISIS. These are augmentations to the base. I wouldn't put too high a priority on these until we get the base done. I mean, we can definitely start the process though. the distinction of these drafts is the last drafts that don't have LSR, last working group drafts that don't have LSR in the title from when we merged the working groups about 5 years ago. I'm not going to say anything.
Was it really 5
We're
years?
going to cover, what's that, Chris?
It was 5 years ago? That's, wow.
Something like
anyway.
that.
Yeah.
Yeah. We're going to cover flood reduction today. I won't say anything. BFD strict mode, that's been implemented. It's a pretty simple draft. I think we could go through this one actually pretty quickly. And this is one we hope to get done because we have the ISIS sitting waiting for missed refs. So we'd really like to get the OSPF v3 extensions for SR v6 done. The authors told me they're going to have a update soon. I'm not going to say anything much about any of these. We have a lot of working group documents, so we have to, but we should really focus on that rather than taking on new work. We have only one I'm going to say anything about is the flexible bandwidth delay and constraints. There was a discussion on the ASLA that never completed, and today, the generic metric. We didn't really get through that discussion on the list, but now there's a new proposal for ASLA bit. Hopefully we can discuss whether that can resolve the controversy with the generic metric. And okay, we have these two documents, the prefix unreachable announcement and passive interface. That's going to be covered today as well. And so is the flooding draft. And I don't have anything to say about these documents. Okay. Anything to add, Chris, on any of the work we need to do or anything? The one thing I would like to say is I think we should focus on getting, since we have all these working group documents, is getting some of these done as opposed to taking on new work.
Yeah, so let's flip back. Can you flip back to the existing working group documents?
Certainly.
Page 1, I guess, 1 of 3.
Yeah.
So I'm curious, we have all these experimental ones. Do any of the authors of any of these can they report, like, has it been deployed? Is anyone using them? Are they being experimented with? I guess the question would go out to Wemo, Tony. What was the other one? I guess the other one was Flood Reflector, which presented today. But.
Yeah, it's going to be presented. That one has been implemented in discussions. I did an expense review on that one.
Is Tony Lee here? No.
Okay.
Shoot. Is Wemo here? No. Okay. Well, we're not going to hear anything about those then.
Okay.
Yeah. So I guess then I wonder if there's anything else we could say. No, to see if we could push some of these through. I mean, are any of these blocked on us? Does anybody know if any of these are blocked on us, these working group documents? If you want to say, hey, look, pay attention to mine, you guys need to do this.
Let me look at anybody else ask for the reverse metric. They've asked for they've said it's ready for working group last call. It's just the OSPF corollary to the existing
Right.
ISIS RFC.
Yeah.
No,
okay. Let's do that then. Look,
none of the other ones they've really asked for working group last call, and there hasn't been much discussion on the list as we get further on.
Yep. Okay. Then I don't have anything else.
So let's see.
So it's flood reflection. If you stop,
I stopped
then-
sharing flat slides.
Tony P, can you find that little document icon? Oh no, is it flooding speed first? Sorry, I'm sorry.
Okay.
Is it Les or Bruno? Are you presenting, Les or Bruno?
Presenting?
Your slides.
Yeah, can you hear me?
Yes.
Yeah, I'll be presenting.
Yeah, so if you click on the little document.
I clicked on the little document. I don't see anything that allows me to select.
I stopped sharing, so you should be able to. It doesn't
Let
say.
me. I'll share
here,
my
now
screen
it's-
and I'll show you what it looks like, just in case. Let's see. So it's right here. This guy. Is that the one you clicked on?
Yes.
Huh.
Oh man.
Okay. Well. Oh, it says all the slots immediate. Oh. Okay. So maybe it popped something up on your screen, but you can't see it.
That makes it
Grant.
difficult.
Oh, I had to grant. I found it.
You need
I
to
found it.
grant his access. Yeah.
Okay.
I have to
Yeah.
click this.
Yeah, we didn't have to do that because the chairs automatically had access to share.
Can you click the green thing? It's saying already granted on him and Q. Oh, I have to quit the screen share. Okay, now let's try again. There we go.
Ah,
All right.
It's role-based access control.
Yep. My audio I'm getting is fuzzy. Is anybody else getting that? I might reset my audio.
it sounds fine to me, Chris.
Okay, I'll reset then. Go ahead, Les.
All right. Okay, so this is an update on fast flooding. We've now produced a merged draft. There were formerly 2 drafts. And so we have lots of authors. I hope we'll be able to keep that many authors going forward since everybody's contributed. So you're telling me I can move the slides by doing what?
Click an arrow. Oh, your arrow key.
Oh,
or-
I see. I have the numbers. Okay. So in September, the authors of these 2 drafts, which we've been talking about for some time now, agreed to produce a combined draft. That was, I believe, just before the interim meeting that we had on this topic. We had consensus on there are many congestion control algorithms that are possible because they're implemented on the DX side. So it's not necessary for, oh, it's bigger now, cool. It's not necessary that every node implement the same congestion control algorithm. There is also a flow control aspect depending upon what approach you take. And for flow control, we do need some TLVs that have to be supported for interoperability. And we've been debating back and forth for some time about which approach is better. And we've basically decided we don't have to make that choice at this point. What we want to do is to support experimental work going forward in terms of how the algorithms are working. And that's what we've been talking about, I think, the last couple of IETFs. And so the best way forward is to produce a combined draft that provides the tools so implementers can do what they think is best, and we'll see how the what the performance of the algorithms turns out to be, and whether we can settle on one or whether we'll just simply allow for multiple in the future. So this is not a technical presentation. This is basically just a quick overview of the combined draft content. And I've done this basically by picking the key sections in the document and describing the content that's in these sections. So we have a section, an introductory section, and a discussion of historical behavior. Historically, we've flooded at 33 LSPs per second or thereabouts. And this talks about the goals of faster flooding, which is something that we all pretty much agreed upon. So we took some text from both of the drafts, as this was, again, a point of consensus. There really weren't any significant issues in putting this text together. Section 4 discusses a new flooding parameters TLV, which now contains 6 candidate sub-TLVs. The first 2 already were present in draft Ukraine, although we've renamed them a bit. And we introduced 4 new ones, which were related to things that the one or the other algorithm was making use of. Section 5 talks about some performance improvements that are needed on the receiver, particularly acknowledging LSPs more quickly than implementations may historically have been doing, and perhaps prioritizing the reception of SNPs on receive to assist in providing faster acknowledgements. Section 6 contains the description of the 2 algorithms that have been discussed separately in the different documents in the past. So section 6.2 is the algorithm from draft Ukraine. The description has been updated. 6.3 is the algorithm from draft Ginsburg. That description has also been updated, but they're fundamentally the same 2 algorithms that were previously in separate documents. And we added an appendix to track changes and another appendix to track open issues. At the present time, there are no open issues. We managed to resolve all of the open issues that we had during the discussion of putting together the combined draft. But we'll use that to track issues in the future. And now we'd like to request working group adoption. This has been discussed probably for a couple of years now. And we'd like to move forward with the work. And, we will, the respective teams are still doing implementation and testing, and there'll be further reports and update to the draft in the future. I think the most important point here is if we can get quick working group adoption, then we can get an early allocation for the TLV code point, which we need to move forward with the work. And that's it.
Well, I guess
Something happened to the audio?
You see, we started to hear your voice and then it cut off after, I guess.
okay. Yeah, I think we're definitely gonna do, given the interest and the number of meetings we've had on this. This has been probably the most discussed topic on the working group list for a long time. We're gonna do working group adoption immediately. The one question is whether we do standard track or experimental. I think we'll include that in the adoption. We're kind of running short on time. We didn't allocate that much time for this, but we'll do that shortly after the IETF, the adoption call. But anyway, good work. I mean, to everybody on the design, on both of the drafts and the discussion. And I read it. It looks ready for adoption. I'll probably have some more comments, but purely editorial. I don't see anybody else in the queue. I guess we can go on to the next presentation. Tony, you want to put load your slides, or Les, can you stop sharing? And Tony, do you want to share?
Yeah, let's try this experiment. All right. Pushing something.
Okay, do it again. I think let's see.
Oh yeah, look, it looks even.
I granted him. I had to reboot my machine apparently.
Okay.
Yeah, look at this. Something works. Yes, so PDF, you don't really see the title, doesn't matter. Anyway, it's the update on what's going on with the flood reflection draft, version 4. Okay. So yeah, 4 came out. That was based on some discussions and implementation deployment experience. Thanks especially to AC, who really fine-combed the stuff. I don't think how much was on the list, how much was actually authors and AC. So, multiple sections have been changed, clarified, added. So substantially nothing changed, but a lot of clarification has been put into the document. More detailed changes. So glossary, always a nice thing. And then we broke out and clarified the section about the 2 deployment modes, which we call no tunnel deployment, so basically no shortcuts, and L1 tunnel deployment. So basically you shortcut the thing with full or partial mesh of L1 shortcuts, and you use basically the tunnels as next stops. What we also threw in based on already, discussion about some future stuff and implementation experience, we threw in the tunnel type discovery, because so far there was only discovery of whether, where the endpoints are and who is doing what role, but there was no description what kind of tunnel can you set up if you want to set up automatic tunnel. And thankfully now we have the RFC 9012, which deals in extensive detail with the subject. So the acceptable tunnel endpoints, including the caps and all the other jazz that you need to get it done, are being announced. And a flag basically shows up where the endpoint is flood reflector adjacency or an L1 shortcut endpoint. And of course, you can run the stuff just fine with statically configured tunnels or any, tunnel solution that you prefer to, this auto-discovered stuff. All right. Even more detail, that's mostly implementation and deployment feedback. The mask of multiplicities of TLVs has been moved mostly to shoot, and the violation should be logged and clarified that only the first, instance should be used. I think it was based maybe even on ACE's comments. The other interesting thing is that we added the sub-TLVs for discovery of the different roles and the tunnel endpoints. We moved that not only in L1, but also into L2 as advertisement, as the scope of advertisement. That's simply based on the observation that some people desire to run it with underneath not having ISIS L1, but possibly something else. So the advertisement cannot fly in L1, they should fly in L2. Then ISIS metric on all flood reflector adjacencies should be uniform. That's basically from deployment. They don't have to be, but it will save you potentially a lot of trouble if you keep the flood reflector adjacencies uniform in terms of the metrics distances. Then again, deployment and implementation, it wasn't entirely clear that within an area, ISIS area, the cluster ID should be uniform. That does not prevent you technically to run multiple cluster in an area. but it still prevents. I mean, it was pretty clear in the draft, but on the implementation experience, we pointed at stuff. We made it even more clear that a single client has to use the same cluster ID. So the only way he can interact with another cluster would be for a normal L2 adjacency with another client in another cluster. And we clarified also that the cluster ID is used to actually check adjacency formation if you decide to be, a client or a reflector. Right. So alt ends. So yes, this is implemented, and in deployment, what we see is that the numbers in terms of additional scalability you can get with it are pretty much what we expected based on kind of simulation, theoretical work, thinking through the stuff before implementation. And we also see that it does not require forklift of the network, but you can actually move over without losing capacity. So basically one node at a time if you do it correctly. Technically speaking, or in terms of substance, there were no significant changes, right, except all this clarification work that I pointed out. And I think, again, that this is ready for last call. I do not think we'll have any substantial additions or changes. And currently ongoing work, which is already spinning out of it, is the BGPLS, which is, of course, the next thing that is needed, that has been introduced in IDR this meeting. Jordan is doing most of this work there. And we also starting on auto flood reflection, which is the same thing as auto VPN in Rift, which basically means that you can bootstrap routers without any configuration whatsoever, and you end up, if you build some variation of a claw network, you end up with a fully configured claw plus the flood reflection already automatically being configured on top of it. That's the last one that I have, I think, yes. So from my side, or from the author's side, the outstanding request is to go with this thing for a last call and see whether more things pop up. If anybody has implementation, wants to interrupt, and so on and so on, as usual, pretty welcome. Implementation is relatively simple from our experience. So, no, highly encouraged. Thanks, I'm done.
So with the contributor hat on, not the chair hat, I reread the draft yesterday and had a couple thoughts. Have you considered, one of the obvious ways to deploy it is with the tunnels between the L1, L2s for forwarding. Have you considered like just they automatically working, like they're auto set up, not even signaled at all, but, just because of the fact that they're, once they join up with the reflector, then they just, they can program themselves to accept encapsulated traffic from the other clients.
Yeah, right. So that's what the Discovery TLD is there for.
Okay,
right.
So I didn't get, when I read, I just read it, I didn't get that, there wasn't anything sort of saying you don't have to signal this. I thought it was talking about signaling it, but.
Well, depend what we think of signaling. But basically what happens is you send these Discovery sub-TLDs which tell the others what the roles are. And you can optionally add to that sub-TLDs which describes the tunnel endpoint. And say, look, this is the tunnel endpoint for either flood reflector adjacency or for a shortcut. And then there is basically a simple explanation what's the tie breaking, who is initiating, right? And based on that, the tunnels can be automatically set up, but something has to set up the tunnels unless you supported, statically pre-provisioned tunnels, which we also support. And I don't see much more to be done there.
No, that's what I was thinking though, is that not even, like if you knew who the other clients were, you could automatically, as a receiver, right? You could set up.
Yeah, but that's what's happening, right? So in L1, you will see all the other guys, and they will show up as clients in the same cluster ID, and they will show up the shortcut endpoint. So you can build up those tunnels to them.
That's what I'm getting at, is that you don't
Yeah.
even need to signal it. You could just say, because I'm part of this thing, I've got it configured to auto tunnel, right? And so I'll just accept packets encapsulated.
Yeah,
to
but
me
that
from
you
the
have to
client.
know what type of tunnel is supported and what is the endpoint address of the other guy, right? And that's exactly
so
what
that-
we flagged, right?
So that's what I was getting at, is that up front, rather than signaling tunnels, just saying what type of tunnel, and then everyone just does it. Anyway, it's just was a thought about.
Well, so see the tunnel thing, if you talk to 4 customers, what tunnel they prefer, you get 5 to 6 answers, right? So that was exactly the discussion we were having, and we trying to steer them towards, GRE, and every tunnel has its work and silicon support problems, and frankly, the most advanced customers, they end up preferring the no tunnel option. And that's why we worked on that stuff most extensively. So we suggested the whole thing a while ago, and the most sophisticated people actually reject the tunnel option, the shortcut, for lots of reasons, which are often non-obvious, right? Operational, silicon reasons, and so on.
So I have just a follow-up question on the tunnels. You in the draft, I think you might have added the TTZ comparison. It did get me thinking. The TTZ gives you a full mesh of adjacencies, and you're cutting down. That's the main advantage here, is the adjacency. The reflector keeps your adjacency hub and spoke.
Yeah, the L2, yes.
Did they get away? I don't remember, and so I'm asking you about their draft. But do they require tunnels between their L1, L2, between their TTZ edge, or how did they solve that forwarding problem? Did they do
the forwarding problem, they have underneath the full mesh of tunnels, which this draft has as well, right? It's just hidden. That's the difference, right? This draft basically hides the full mesh by showing the a double star. And that's architecturally really, the only difference, and the rest is kind of, mechanics and little smart, curriculums and so on. What is, of course, drastically different is the no tunnel option, right? But this is far more sophisticated to deploy. I mean, this is a much sharper knife, albeit how should I put it? It's very appealing, right? Because you get rid of all the tunnel stuff, and you get very good, properties in terms of scalability. But you have to know what you're doing when you start to flood all the L2 into L1 and L1, out in terms of frequencies. Yeah, but it works. Yes.
Let me. Wimo's. He's not in the queue, but he's put in the chat. TTZ does not use tunnels. Yeah. Okay.
Can I speak for a second?
Yeah.
I think for OSPF TTZ, for the TTZ edges for the connection, they don't use tunnels. They use the shortest path, because that's for the forwarding from one edge to another edge, TTZ edge. They just use
that's because you so you advertise all the outside reachability into the TTZ then?
Yeah,
that's why.
The advertisement is full mesh.
Yeah. No, I got you. So you don't use tunnels, but you do have to advertise all. In this case, in the context here, you would be advertising all the L2 into the L1. Okay. Yeah. Okay. Cool. Thanks. I don't want to take up any more time. We do have a lot of slop. We have like 20 minutes of slop, but.
Yeah. I mean, I remember the TTZ differently, but it's a while since I read it. When there were initial discussions ages ago when I was in New Mexico about, why the whole thing would loop, and then the full mesh came up and so on. Yeah, but this thing was specifically built to scale up L2, right? So we couldn't plot all the stuff into L2, and then the L1 does underneath what L1 needs to do. Yes. All right. So.
Thanks.
Hope that was enlightening to a point. I think the draft is now very, very detailed. If somebody wants to attempt an implementation.
Yeah. This is AC speaking as working group chair. We went through some iterations, and we handled all the things that myself and other people had said needed to be clarified, and I think it's ready too. I'd like some of the longtime ISIS developers like Stefano, Shraddha, Les, Ahmed, and some of the others. I'd like, it would be good if you would review it as well. Oh, Bruno.
Yeah, why don't we go hunt down Hank Schmidt? Where's he?
Yeah.
Cisco back again, all I heard, yeah.
No, Nokia, I think.
Oh, true, yeah.
Okay.
We
but
can take it to the list, but it sounds like we'll put a working group last call out then on the list.
Yes.
Cool, excellent, thanks.
Thanks. Shraddha's next, right? Yes. Shraddha, can you load your slides? Okay.
We did. We just aren't used to hitting the green button, I think.
Yeah.
I did it.
Are you?
You're muted. You have to click the little mic icon.
There.
Shraddha.
Yeah, can you hear me now?
Yes.
Now we can. Yep.
Okay. So I'll be presenting the application specific link attributes, any application bit on behalf of my co-authors. So we'll look at what problem we're trying to solve with this. We'll look into some of the details of protocol extensions and how is the backward compatibility handled. So the problem statement is that network operators may want certain link attributes to be used by all current and future applications. So, and we have many examples of such attributes and how the network evolved over many years. So, and we have made ASLA mandatory for some applications such as FlexAlgo. So ASLA allows for an attribute advertisement where link attributes applicable to one applications or some applications or all the applications currently defined. But there's a limited provision to advertise attributes that are applicable to any application which are currently defined or going to be defined in future. So the reason why we call it limited support is because RFC 8919 and 8920, they do not allow application to use attributes from zero length. So there is a zero length SABM. If you advertise attributes under that zero length SABM, then any other any application can use it unless the application has any other attribute advertised with an application bitset. So during a discussion in the mailing list, there were opinions that more granular control over attribute advertisement for any application versus application specific is useful. Like some attributes, operators want to design it in an application independent way so that those attributes are always available for any application that are currently defined or defined in future. And some specific applications may be designed to be used in an application specific way. So this we're trying to solve this problem where this can be this control can be provided in ASLA. So the details of protocol extension. So so any bit is a standard bit mask, and it's bit number 4. So that implies that any application. So any attribute advertised under this can be used by any application. So how to achieve backward compatibility? So obviously, a node that does not understand a bit, it cannot process the attributes under the advertisement which has an ASLA TLB which has an a bit set, so it ignores that. And processing of the other bits that remains as per 8919 and 8920. And this draft mandates that if same attribute is advertised under ASLA with a bit and there is an advertisement under ASLA with specific application bit set, the one which is application must use the one which has the application bit set. I know that takes the precedence. So this is in order to avoid so let's say some nodes are upgraded, they suddenly start advertising attributes with a bit set, and the older nodes, they will pick up attributes under the application specific. So that's the reason even the ones which understand the a bit will have to pick the attributes which are under a bits under the application bit set. So until all nodes are upgraded to support a bit, obviously the nodes won't be able to use the attributes which are advertised under a bit, and hence the upgraded nodes also would have to advertise in the attributes under a bit as well as under application specific bit set. And the processing of the SABM with zero length continues to follow 8919 and 8920. Nothing is, this draft doesn't modify any of those procedures. Yeah, request further review and comments on the draft, and and also request working group adoption. And one more thing I want to clarify based on the on AC's comment in the beginning of the meeting today. So this is quite independent from generic metrics. So this is just trying to provide for network operators who want to design certain attributes in an application independent manner and advertise them. This is just giving that possibility so that those attributes can be advertised in an application independent way inside ASLA. Yeah, that's the clarification. Any questions, comments?
I guess
AC,
I'm
you're
at the,
you're at
Yep.
the top.
okay. Yeah, I realized that this didn't get us off the hook for the discussion of the continued discussion of the generic metric. The one question I have, if you have the A bit set and other bits, you're going to use the whatever is advertised in that attribute in either case. So what's the advantage over the A bit over the zero length bit mask? I mean, you know, the I forget the acronyms for them. What's the advantage of that? I couldn't see that.
Yeah, so the difference is that so let's say if you if you have designed one attribute, let's say admin group in an application independent way. So in your network, right? So red color means 1 gig link, and that means this red color is any application can use this red color, this admin group. So admin group is an attribute which is designed in the network to be used by any application. So now you can advertise it under a bit. And there are some other applications, some other attributes that you want to design it in an application specific way. For example, you want, there is some, let's say, some bandwidth related attribute that you want to design it and advertise it in an application specific way. So different for SRT, different for FlexAlgo, and so on. So you can do that. I mean, you can advertise that one under the bandwidth one under the application specific bit set, and the admin group under a bit set. So whereas if you advertise the admin group under SABM with all SABM with length 0, and then for, let's say, for FlexAlgo and SRT you have advertised bandwidth, now you cannot use the admin group for SRT and FlexAlgo because they have the application bit set. So basically, it's giving you an opportunity to advertise attributes in an application independent way on a per attribute basis.
So long story short, because this is related to my question. Sorry to jump in front of you, Les, but my question is the same except different, which is I understand why you did this because the zero length can't be used the minute you use a non-zero length. That's what you're saying.
Yeah.
Like, so one attribute uses zero length, everything's golden. You do
Okay.
another attribute with a specific, and then all of a sudden you have to stop listening to that zero length. To me, that
Right,
seems like a fault in the original design. Like, why don't we just fix that? Like, why is it even that way? And maybe Les can answer that question.
Yeah, I will let Les answer that question. Maybe I can
Is it my
follow up
turn now?
after Les's answer.
Is it my turn now, Chris?
Yes.
Yes.
Okay, so we've had extensive discussion about the technical issues on the list, including the points that AC and Chris are asking about. I don't want to go into that here. I don't think we have the time to go back and forth. The point I want to make is kind of a much larger point. The function of the IETF and the function of our working group is to produce a standard that supports interoperability. We have done that with the ASL RFCs 8919, 8920. The authors of this document have decided that a certain portion of the way to support all applications or any application, if you will, is not to their liking. And so they've proposed an alternate form of advertising this. The two definitions, the zero length definition that exists in the ASLA RFCs and the ABIT that's defined here are not compatible, despite what Shraddha has presented. In a real deployment, all of the nodes that are operating in the network have to advertise things the same way in order to understand each other, or they have to advertise things both ways in order to make sure that if a node's supporting one strategy versus another, that everything is understood. This now puts us in the position of, instead of having a standard which everybody can use to support interoperability, we now have multiple published solutions, some of which are favored by one set of people and some of which are favored by another set of people. This introduces a lot of interoperability issues. It requires vendors to do multiple implementations of the same functionality, not because one of the solutions is deficient, but simply because some folks have decided we prefer to do it this way. And this, to me, does not serve the industry.
Yeah. Okay.
So
This might be getting a little bit. It's this philosophy. Okay. It's requesting working group adoption, right? I mean, we haven't published two competing standards.
This
right?
standard.
So your point is fine, right? But we're not like breaking the internet, right? What you're saying is they're proposing a solution and it's not compatible. That definitely should go into what the working group does, right? I mean, no, we don't want to publish two things that compete with each other or cause problems. So that's a great point, but let's not take that too far, because this is just a draft, right? So that's a reason not to go with it, in your opinion.
Correct.
Right? Okay, great. So we're out of time on this. The question that I was asking, I guess you're saying go read the list, dummy, is why the zero length can't be fixed. It sounds a little broken, but we can do that on the list since we're out of time. And you're saying,
sure. And with this, just one comment with respect to Les's observation. So I think it's not right that the two solutions are not interoperable. how they can interrupt has been discussed just now in the previous slide. I mean, it's not clear, we can discuss again, but I do think that this very much interrupts with whatever has been deployed in 8919 and 8920. It just
I mean,
gives
this is
another
something
option.
Let's do it on the list, because I mean, showing something doesn't interrupt is pretty easy, right? I mean, and we can all technically look at that and look at the example. I mean, you usually can show an example, right? So if Les is right, he'll throw an example out and we'll all go, yep, Les is right. And if Les can't come up with an example, then you're right. That's easy enough, right?
Yeah. The one thing
Sure, we
that
can
stuck out
take it to the list.
yeah, we'll take it to the list. It stuck out in my mind. It said when everybody is upgraded, and there was nothing in the protocol to do that. It seemed like it was an operational interoperability and not a protocol interoperability. But anyway.
Okay. Who's up next?
Arjun.
Gien or Aijin?
Oh,
Puum and passive. Okay, so we need to drop. I think I can just knock this down. Aijin, okay. So you hit your little document icon, you did, and I hit your green and you get it.
Okay.
So make sure you hit your mic, little mic icon, so we can hear you. There you go. Oh, you're sharing your screen. No. Don't do that. Don't do that. Click the little document right next to the monitor. Between the hand and the monitor, there's a little document icon. Aijin. Click that.
We can't hear you either.
But yeah, and I can't hear you talking yet, so that might also be another problem. Okay, that doesn't look like the icon, but okay. Yeah, that's not the right thing. Click next to it. Do you see the little document? Okay, never mind.
What's the second one?
It's okay. I guess you can share your screen, but we can't hear you. So, can you talk? You have to click the mic icon.
Yeah, you have to click the mic. You're muted.
Okay, say something.
Hello?
Yes.
Now we can hear you.
I try to share a screen, but it did not work, I think.
We don't do the screen. You click the document. See
Right next
you see
to
the
the
monitor
hand.
up there? You see
Oh, not the screen, but the document. Okay.
Yeah, just go ahead and present. Okay, or don't. Yeah, it's going to say you're okay. You have to stop doing the screen. I'll do that for you. Hang on. Yeah, and then that one works. There we go. Okay.
Okay. Oh, okay. Hello? It work now?
Yes.
Yes,
Okay.
I put it down to 12 minutes. We're starting to run on a slot.
So let me start the instruction. I will instruct two documents. The first is the prefix unreachable announcement mechanism. I think this has been discussed intensively on the main list. So I think we are familiar with the scenario. So I just describe the solution directly. The POM solution, there are the main step is upon receiving the node link failure information, which prefix is within the range of the advertised summary address, the ABR or L1 or to boot router will generate one new summary address with the failure prefix associated, but set its originator information to null. And we use the IPv4 and IPv6 source router in IS and OSPF. So such summary message will be flagged across the boundary, a normal OSPF and IS procedure. For node failure scenario, so one node within one area receives such message from all of its ABRs, it will trigger the switchover of the control plane for the overlay service, such as BTP or GRE tunnel service that is run on top of it. For link failure or only some of the ABR can reach the prefix, that is we call the network partitional scenario. So then when only some of the ABR can't reach the failure prefix, the ABR that can reach the prefix will advertise the specific route to this POM prefix. So this procedure is same as the RIFT. And ABR will only send out such message when all the internal router support such mechanism. And ABR can also control when to send out such message based on ACL-like configuration. That is to say, it is when some link or some link failure, but it is not within the interested prefix. So the ABR should not send out such message. So it is keep the original performance of the IDP. And to achieve the ABR know the capability of the OS internal capability to support the POM. So we add back for the capability announcement from the previous version. So the node within one area should all support such mechanism to ensure they act correctly based on such information. We also add the consideration for OSPF v2, v3, and IS. There is a similar proposal by Les and Peter for the event notification solution. We have discussed the solution online or offline, and here just our conclusion for the event notification solution. Proper one general event notification container within IS to deliver the positive or negative pulse event based on the flooding scope LSP RS 7356. Currently, it is focused only on the same use case as the POM job. And based on the discussion, we think for POM and for the current use case, both solutions can achieve the same result. But for POM, the existing LLTPD format and procedure can be utilized. And the solution is the same procedure for OSPF and ISS. And we think it is easy to implement, deploy, and debug in the product network. And there we also consider some misbehavior for the unsupported node, but we have think such misbehavior can be controlled. In deployment. And for event notification solution, we think it is almost the similar procedure as the POM. The difference lies mainly how to encode such message. And we think for general solution, such general event notification solution, it should be compared with other existing solutions for the potential requirement, because it is not able to solve only the prefix unreachable announcement. We think because currently there is only one use case for such mechanism, we think it is a nature to introduce the general pulse mechanism within IGP currently. And for OSPF, there is another solution proposed by Huemo about 10 years ago. We also need to consider how to implement such event notification in OSPF and in IS. So for action, we think this is topic have enough interest on the list, and we think it is the time for adoption call for this software. Okay, let's first discuss this software, and after the question, I will introduce the next one.
Yeah. So go ahead, Les.
So I will.
Comment I want to.
Okay.
No, Les is in the
Okay.
queue. Just let Les. Go ahead.
Okay, the comment I want to make, I think the discussion on the list has highlighted the fact that there's an open question as to, independent of whether we use the prefix unreachable draft or the event notification draft, as to whether this problem should be solved by the IGPs or whether it should be solved by BGP or some other way. And I think the logical way to proceed on this is to get consensus of the working group as to whether an IGP solution is desired first. Then after we reach consensus on that, then we can start talking about which approach is the better approach, and which one should be adopted.
Yeah. So chair hat on. They've been asking for adoption for a while. The event thing is new. I agree with what you just said, Les. In a perfect world, that would be the case. But then again, asking for adoption is one way to answer that question. It may be not the perfect way to answer that question, but it is one way. And I mean, I agree. Without my chair hat on, I'm not sure we need this, right? But it's not for me to say by fiat. AC did put something out on the list to try to engage people again, and I don't think a lot got said.
Yeah,
So go ahead.
Okay. Go ahead, finish, Chris. And
No, that was all I was going to say. Aijan has another presentation. He only has got 3 minutes left.
I want to share the document, but cannot.
You got to share the same thing again. Yeah.
Yeah, just
Okay.
just what he's bringing
Yeah.
that up. I didn't see much support other than the offers, and I saw one non-offer supporting the event notification. So when I did,
but I think it's fair. Everyone has a right to ask for an adoption, and
right.
I don't know. So if and everyone has a right to say we shouldn't adopt this, and these are the reasons. We've sort of been letting it percolate to try to get people to express opinions, and without seeing a lot of negative opinions, it's hard not to just grant the adoption call.
Tony, do you have a quick thing to say?
Yeah, I think so. I think this is all trash canning the IGP. I mean, nothing new has been done forever because, hey, that's broadcast everybody can get everywhere. One possible solution is to ban or encourage maybe everyone with these kind of suggestions to go towards the service instance stuff or whatever we call it, which I think is a good idea. Just run a parallel IGP at much lower priority and don't trash the main thing that holds the whole thing together.
That sounds like a great comment for the adoption call, or for coming out before. But yeah. And as a working group member, I agree with you. Okay, we got to move. He's got a minute and a half. We got 4 minutes of slop left in the entire agenda. Go ahead, Aijan. Aijan, go. We can't hear you.
It looks like you're sending audio, but we can't hear you, Ajun.
Yeah.
Maybe the local mute button in the lower right is clicked.
I don't know.
Yeah.
Oh,
Well, why don't we move on to the next presentation? And if we have time at the end, we'll come back. Ajun, you've got to figure out how to get yourself unmuted. You've got a different.
Okay, no
Oh,
problem.
now you're there. But let's come back to your presentation. If I'll try to bring people in tighter and see if we can come back to it. Okay.
Okay, no problem.
All right. Thanks. Sorry. Okay. So next up is Linda.
Hi, can you hear me?
Yep. Click your little document icon next to the hand.
What do you mean? You want me to present or what?
Yes, you're going to present. Click the little document icon to the left of the hand icon. Top left. There you go. There, and now you're in control.
Oh, okay.
You should see the slides come up momentarily.
yeah.
There you go.
Oh, okay. Good. Okay, thank you very much for giving this opportunity. And next page, please.
You're in control.
Control. Hit the arrow. Right.
Oh, okay. Good. Thank you. So this is about LSR, ISI's OSPF extension for serving the 5G edge computing services. Sorry. So I have to thank Peter for helping us offline to shape the content, make it so much shorter and to the point. And many thanks to other people on the mailing list discussion to help shaping this draft. Okay. So a little bit background. So this is for the edge computing environment where the servers are very close to the proximity of the 5G sites like UPF and PSA packet session anchors. And for the mission sensitive applications, it is very common to have multiple servers for the same application all close together. There are many use cases being discussed in 3GPP for this kind of applications and this kind of deployment. And so for the ITP domain, you may have a small set of like routers, and then the egress router will have the servers, edge server, edge computing server directly attached to the routers. So this is the basic background. So very frequently, Anycast being used. There are many benefits of using Anycast. Basically, is to leverage the network condition to distribute the packets, so that if there's changes in the UE behavior, like for example, lots of users move to one location for like concert or conference call or gathering, and the servers nearby that cell tower may be overbooked, overutilized. And at this point that like the network routing distance to the others may be very small difference. So compare with the utilization of the server, so that the network itself, if Anycast is used, can automatically migrate the traffic to the location where there are less utilized servers available, compute available. And also it is make it possible to eliminate the single point of failure, like a DNS resolver or the load balancer. Like typically today we have the application layer load balancer, which has many servers attached behind. But to the network, there's only one address where we see the network load balancer. But if the condition to the load balancer has some issues, then impact the performance. So using Anycast can eliminate that issues. Also, many clients may use stale IP addresses. They may only retrieve the IP address once a while. So that when they move from one cell tower to another cell tower, they may still have the old IP address. And this is become more acute in a 5G environment, because in 4G, you don't have that much issue. 4G, maybe the entire city only has one packet gateway. So everybody traffic, doesn't matter where you move to, unless you drive very far away, your traffic all anchored into the same ingress router to the IP network or the same packet gateway. But in 5G environment, there'll be many those user plan functions and the packet anchor points, so that when user move, the traffic move and their associate the local network routers, they were going through the different ingress routers. So that's basically the benefit of using Anycast. And then this particular contribution of the draft is to bring up another layer of matrix in compute the path, shortest path. Since those servers, they are attached to the egress routers, and like for example, the site can have different value or preference, and they may have different capacity, and so we want to bring this information into the IGP's constrained path compute. Okay. So the overview of the solution is pretty simple. So one thing is the egress router need to advertise the site cost of the in the IP prefix reachability TLV to indicate the value, the cost value to reach specific prefix. And bear in mind that not every service in this LDN require this preferred or specialized path compute. Only a small set of prefix. Like for example, if you use this AWS wavelength zone, right? If you want low latency service, as a client, they have to register their service with the provider. So the provider is aware of a small set of services or IP addresses in our context that require this special treatment. So this is and then we're using the flag algorithm. There's a new flag set to indicate that for this specific prefix that you need to consider the site cost to balance the actual cost to the specific prefix. So that's the basic overview of this. And then for the flags algorithm definition, flag sub TLV, we introduced a new flag to indicate that this site cost matrix need to be included to derive the constrained path to the prefix. So that's just a new flag need to be introduced. Once this new flags to be introduced, and then as an egress node, it can advertise the cost, the aggregate cost, which include the like a load index. The egress node may measure the packets to the node or from the prefix to the prefix, and also including the site preference and other parameters. They compute aggregate cost, and this cost can be advertised. So in OSPF v2, we can add a new sub-TLV to be added into the extended prefix TLV to indicate the cost. In OSPF v3, that a same new sub-TLB can be appended to the extended prefix LSA, which is described in 83.
Let's get to people. I think you're at the end. Let's get to the people in the queue.
Oh, okay.
Yeah.
Okay.
Because you want feedback. So here's your feedback. Shraddha?
Yeah, Linda, thank you for the presentation and describing the use case. So if I understood correctly, what you're trying to do is you have multiple application servers. They are represented using an single Anycast address. And then you really want to load balance the traffic onto these application servers. So to me, it looks like it's a problem of load balancing onto the servers. And probably what I feel is metric probably is not the right way, because the moment you change the metric based on load or preference or whatever, your traffic gets skewed towards that metric, and then you have an oscillation, right? And you have more UEs connecting to this particular servers because this metric looks better. So because you're describing this as a load balancing problem, what I think you really want to do is to use the factors that you have described, like the load, the preference, and the site cost, etc., to compute the balance and use it as a load balancing mechanism, basically unequal load balancing on ECMP Anycast prefix.
But Shraddha, how do you do that? So Linda wants to use the network function, the routing function, to do the load balancing. How do you do that without using a metric?
Yeah, so that makes me think I mean, you can do it with PG.
You're right. I mean, the hystereses here are very important, right? Because if you add one client to the thing and then the metric changes and then you're bouncing back and forth between the two sites, right? For each client that gets added. So you have to put some kind of hystereses on this so that that doesn't happen. But eventually that is what you want to happen, right? That's load balancing. You know, going back and forth between the two. You just maybe don't want it to happen on a per client, per one use.
Exactly. So to me, it appears that it's a load balancing problem, and changing metric isn't really going to solve the problem. So I think there are other ways of doing it, and even IGP, right? The load balancing is generally done on next hop. If you have equal next hops, you can do load balancing. You can do unequal load balancing as well. But on an Anycast prefix that is multi-hop
away, novel idea. I mean, she's come up with a novel idea, right? It's moving the load balancer harnessing the route function for load balancing. So it's hard to come up with counter examples if it's novel.
Can I jump the queue? My comments will be related to this discussion.
Yeah, we're actually out of time, so everyone else go fast, I guess.
Thank you very much, and we can continue discussion on the mailing list.
So I just had one. Two quick comments, Linda. The first one is, it looks like as the draft evolved, you forgot to remove sections 8 and 9, the one on the link metric and the one on the stub link that gives a nod to the stub link draft, which is also I think you want to remove those two sections. Can you look at that?
Yes. I have to remove a few sections because just last few days discussion with Peter, and I shrink the slides, but I haven't got a chance to
update the draft. And the other one is, if you're not using the raw metrics, if you're just using an aggregated metric, you can do this today with, irrespective of all the problems with load balancing using routing that Shraddha and Chris were discussing. You could do it just with base OSPF. Just make them the Anycast address an external route and use a type 2 metric. That's your for the external metric. That's your type 2 metric there, and it all works anyway. But if you're going to use the raw metrics and have constraints on those, that would be more of a discussion we can have on the list.
We got to move to Jing. We're 100%. We're 100% out of slop at this point. So next presentation. Thank you, Linda, and we'll take to the rest of the list.
Okay.
Jing, you're ready. There we go. perfect. I'm going to bring it down to 8 minutes. If you could try to pull it in, that way we can have time for discussion.
Hello, everyone. I'm Xixin from Huawei. My topic is IGP extension for pass MTU. Next slide. We know that SR leverages the source routing mechanism and process MPLS labels or SR value side in the packet header. However, the current mechanism in SR do not have the specific path contract signaling so that the path MTU information cannot be abandoned in advance. Therefore, it cannot be ensure that the packet size is less than the path MTU. This draft provides the necessary SS and OSPF attention for advertising the link MTU. Particularly, we define new link MTU sub-TLV for both the SS and OSPF protocols. With the IGP forwarding process in the distributed signaling of the BGP transmission to the controller, the ingress node of the controller is able to compute the path MTU for the SR policy. For the SS extension, we define a new sub-TLV called link MTU sub-TLV to carry the MTU of the interface associated the link. The link MTU is advertised as an optional sub-TLV of the 6 red market TLVs. The length of the types field, the last field, and the value field are 1 byte, and 2 byte respectively. The type values need to be determined. For the OSPF extension, we define new sub-TLV called link MTU sub-TLV for OSPF v2 and OSPF v3 to carry the MTU of the interface associated the link. For OSPF v2, the link MTU is advertised as an optional sub-TLV of the OSPF v2 extend link TLV in the OSPF v2 extend link opaque LSA. For OSPF v3, the link MTU is advertised as an optional sub-TLV of the root link TLV in the OSPF v3 e-router LSA. The length of the type field, the length field, and the value field are all 2 bytes. The type values for OSPF v2 and OSPF v3 can be different and need to be determined. After submitting this draft, we received some feedbacks. Thanks for these feedbacks. According to these feedbacks, first, the title IDP extension for link MTU may be more appropriate. Second, the OSPF TLV need to be bounded to 4 bytes, and thus a 2 byte received field is pounded before the MTU value field as the following format. Okay, that's all.
Yeah.
Thank you for your listening. Any question?
It looks like there's a couple people in the line. I would just throw out the comment that after reading it, I think your tie break should just be lowest MTU and forget all that stuff about encoding IDs and all that. Go ahead, Jeff.
Okay, thank you.
Questions. We have 3 minutes, so Jeff Haas, you're
Sorry,
in the...
I was fighting with my microphone.
Yeah, okay.
So my criticism is not specifically targeting how do we carry this inside of the protocol mechanism. My comment to you is that the general issue that we seem to run into in the real world is that we can't believe what the protocols are telling us in a lot of cases. So I know that you want to carry this stuff in the ITP to signal to some front end. Here's what my path should actually be. Whether you believe it or not, it's actually far more tricky. Having the graph of the individual MTUs for the links will give you roughly the same type of information. My suggestion to you is, please take a look at the contents of the very simple BFD draft that's exposed here. It can be carried in things like SBFD. The general problem that you're going to have is you're told the path MTU is X, but some component link that may be part of that path, part of a backup link, part of a fast reroute scenario. Pick any number of scenarios. The path MTU is not going to be what you actually are told that it is, and it's important to not trust that. That's my comment. Thank you.
My turn?
That's yep.
Yeah. So I share Jeff's concerns. I have a limited enthusiasm for this draft, but my comment is in regards to ISIS, if the working group decides to move forward with this draft, there are already 2 code points that potentially can be used to advertise this. One of them, particularly the per link advertisement, was defined by Trill. It would require a bit of adaptation to be used in this context, but I think it's quite feasible. So I'd like us not to allocate yet another code point if we decide to move forward with this for ISIS. Thanks.
Thanks, Les. AC.
Thank you.
Yeah, we've got, my comment, speaking to working member, is we've got along without this for decades. It seems like just a protocol, bringing this in because it can be done. I don't know. I looked at the use case of SR, and what I would typically do is you don't, if you want to generate MTUs, I would just take the lowest one in the whole domain and use that as my sending MTU, so I could make sure that any opposed labels,
I think that's what they're kind of doing.
They're kind of doing okay, but then you need it. Then you just use a capability and do it on a node basis instead of a link basis. That would be a different way to do it.
Yeah.
The other
okay. Well, these are good. These are good list comments.
They are.
I'll throw out there that we're tunneling like crazy, but in the last 5 years or so. So
that's
getting worse. It's getting worse and worse. But yeah. Anyway, these are good. Let's have the discussion on lists. It's a new draft.
Sounds good.
Thanks, Jing. All right. We might be back on time almost. Ran.
So.
Maybe not.
It's my turn. Hello, Chris?
Yeah.
I'm coming.
Yeah, Zhao. Sorry, I skipped you. Okay, you go. Sorry.
Okay, that's all right. Can you see my slides?
Yes.
I'm going to cut
good.
you down to 8 minutes as well, just to make sure we get in questions.
Okay. Hello, everyone. It's Xiaoming speaking. This presentation is on signaling flow ID label capabilities and the flow ID readable label depth using IGP and the BGP LS. This is the first time I present this individual draft. The latest version is 01. Okay. This is a short draft. The intention of this draft is to define a mechanism to signal the FLC and the FRLD using IGP and the BGP LS. Here, FLC stands for flow ID label capability, which is the ability to process flow ID labels Here, FRLD stands for Flow ID Readable Label Depth, which is the capability of reading the maximum MPLS label stack depth and performing Flow ID label-based performance measurement. We already have obviously 9088 that defines the mechanism to signal entropy label capability and the entropy readable label depth using ISS and the BGP-LS. And we also already have obviously 9089 that defines the mechanism to signal entropy label capability and entropy readable label depth using OSPF and the BGP-LS. This draft is written modeling after the two RFCs. This chapter results from an MPLS working group document that's called Draft IETF MPLS in-band PM encapsulation. In that document, Flow ID label and its usage are defined. This figure gives an example format of MPLS data packet that includes Flow ID label. In this example, Flow ID label is presented twice within the label stack, and each Flow ID label follows a composite special purpose label, CSPL. Each CSPL is composed of two labels. They are extension table label and Flow ID label indicator. Considering the size of the whole label stack, in later revision of this MPLS document, the CSPL may be changed to BSPL, base special purpose label, or BSPL plus bitmap. Anyway, that potential change won't affect the availability of this draft. This slide demonstrates how to advertise FAOC by ISS. 1-bit FAOC flag is borrowed from the prefix attribute flags that's defining obviously 7794. The borrowed FAOC flag is bit number 4, which is next to the ELC flag, defined in section 3 of obviously 9088.
Are you going to comment now, Chris, on that, on this?
I was just getting in the queue.
Okay.
Because you only have 3 minutes left, I don't think you have to necessarily go through every encapsulation here.
Okay.
Maybe just stick to the main points.
Okay, I see. I can skip all the encapsulation.
I mean, just talk about what you're advertising. You know, I think it's important to point out that you're advertising it per prefix because that's going to come up.
Yeah. So this chapter just model after the RFC 1988 and 1989 to advertise the Flow ID label capability and Flow ID readable label depth using IGP and BGP-LS. So that's the intention. That's the point.
Yeah. Okay. So is that your last slide? I thought.
I can go to my last slide.
Yeah.
Wait a minute. Yeah.
So this is pretty new. My comments are quick. I don't know why you did prefix. You say it's useful, but whatever. We can talk about that on the list. But you also say that every interface has to support it. So it's almost like when you propose to like somebody, I'm going to sell you a car for $1 billion, and then they say that's ridiculous. I'll give you 500. I wonder if you're trying to like get it in there by doing that. Anyway, my main comment is if this doesn't have to do with routing, this
Your
reminds
audio
me
is not clear to me. Sorry, Chris. Your audio
What?
is not clear to me.
Okay, yeah, never mind the first comment. The second comment is if it doesn't have to do with routing, it shouldn't be in the IGP. So unless the FLC is affecting forwarding, it's a management thing and it should be somewhere else, is my opinion as a working group contributor. But just like iFit came into the working group and they wanted to do things that didn't have to do with forwarding, they wanted to signal capabilities that didn't have to do with forwarding. I think that violates what an IGP should be advertising, right? That's my opinion, working group chair, not as a working chair.
I understand. Yeah, I understand your point.
Okay.
FLC is used for performance management. It's not for direct forwarding. You are right.
Right. Yeah, that's what I read. But I want to let other people talk. AC or AC in the last.
Yeah, mine's real quick. I'm going to try and state your first comment more simply. RFC 9088 and 9089 advertise this these MPLS capabilities on a link and node level, yet you put it at the prefix level. I don't know why you put it at the prefix level. It seems like this should have a similar form and structure to those two RFCs as opposed to advertising things on a prefix. And we can talk about this on the list.
Yes, I can check that. Thank you, AC.
Okay. Les?
So first off, I agree with Chris's comment about this not necessarily being appropriate for the IGP. I think the mystery about why you've chosen prefix reachability is you've been misled by the entropy drafts, because we had a special case there where we wanted to advertise entropy capability out of the area. And so we needed to use a prefix reachability advertisement to do it. But it's really a node property. And what you're talking about here is also a node property. So if we were to advertise it, it should go into router capabilities. But again, I agree with Chris's comment that this may not be appropriate for the IGP. Thanks.
Okay, thank you. Thank you, Les.
All right, thanks, y'all. We got to move on.
Thank
so
you.
Up next is the Anycast property, Ron. Wow, ready to go. Bang. I wonder why this one's taking longer.
I see that. Shoot.
Very, very quiet. Yeah, probably too quiet. Can you get closer to the mic?
Turn up your
Yes.
volume.
Okay.
Yeah, much
Hi.
better. Yeah, much
Okay.
better. Thank you.
Okay. Hi, everyone. I'm Zan from ZTE. Today, I would like to talk about updates to Anycast property advertisement for SPF on behalf of co-author. Next. Oh, sorry. Sorry, I can't. I can't control my slide.
Have a arrow key on your keyboard?
Yeah. Okay. I found the button. Okay. Yes, this is the motivations. Both SMPS prefix state and IPv4 and IPv6 prefix may be configured as Anycast, and as such, the same value can be advertised by multiple routers. So it is very useful for other routers to know that the advertisement is for an Anycast identifiers. RFC 7684 defines OSPF v2 OPIC LSA based on TLV that can be used to associate additional attribute with prefix or links. 8-bit field of the OSPF v2 extended prefix TLV is used to advertise additional attributes associated with the prefix, but the definition of unicast flag to identify the prefix as unicast has not yet been defined. And however, 3 bits have been defined. For RFC 8362 extends the LSA format by encoding the existing OSPF v3 LSA information in TLV and allowing advertisement of additional information with additional TLV. Each prefix is advertised along with an 8-bit field of capability by using the prefix options, but the definition of unicast flag to identify the prefix as unicast has not yet been defined. And however, only the final bit in the prefix options is not used. So this document updates RFC 7684 and RFC 8362, and we introduce a variable length prefix attribute TLV for both OSPF v2 and v3 that can be reused in multiple or different LSA as sub TLV, and we also introduce a new flag, unicast flag in the prefix attribute sub TLV to advertise the unicast property. And this flag is for the variable length prefix attribute sub TLV. So in the case of OSPF v2, the prefix attribute sub TLV is a sub TLV of the OSPF v2 extended prefix TLV as defined in RFC 7684, and in the case of OSPF v3, the prefix attribute sub TLV is a sub TLV of the intra-air prefix TLV, inter-air prefix TLV, and external prefix TLV. For the next slide is for the attribute, the definition of attribute TLV. For the OSPF v2, the following flag, please see that the first figure has been defined, and the first 8-bit are reserved for the previously defined USPF v2 extended prefix TLV. For the for the A and the N bit, please refer to RFC 7684, and E bit, please refer to RFC 9089. And in this document, we defined a new flag, AC flag, and the new flag is used to advertise unicast property. In the case of OSPF v3, please see the figure 2, and also the first 8-bit are reserved for the previously defined USPF v3 prefix options, and the AC flag is used to advertise the unicast properties. So we have defined the following processing rules for AC flag. The first is when the prefix is configured as unicast, the AC flag should be set. Otherwise, this flag must be clear. And the second is if both N flag and AC flag are set, the receiving routers must ignore the N flag. And the third is AC flag must be preserved when the prefix is propagated to, between areas. And the last is the same prefix can be advertised by multiple routers, and that if at least one of them sets the AC flag in its advertisement, the prefix should be considered as unicast. In the last slide, the last slide is for the processing rules about the prefix attribute sub TLV. The first is if there is a device in this network that don't support instances of the prefix attribute sub TLV, then the device that supports the prefix attribute sub TLV should advertise the field of the capability of the prefix by using prefix options or prefix flags and the prefix attribute sub-TLV. Otherwise, only use the prefix attribute sub-TLV to advertise the field of capability of the prefix. And the second is if prefix is advertised along with the field of capability by using the prefix attribute sub-TLV, then the field of capability of the prefix in the prefix attribute sub-TLV shall prevail. And as long as the prefix attribute sub-TLV is used to advertise the field of capability and the device supports the prefix attribute sub-TLV, then the field of capability in the prefix attribute sub-TLV should be prevail. And the last if prefix is advertised along with the field of capability by using only the prefix options or prefix flags, then the field of capability in the prefix options or prefix flags shall prevail. Yes, this is our presentation. That's all. Thank you. And request review and feedback from working group.
I guess I'm at the top of the queue. AC Lindum speaking as member. The first question is, what is the use case for Anycast? I thought the whole idea was is that it was transparent. The routers didn't know that it was the prefix of Anycast. And the second comment I have, you say that you would not have to use the former. If you use this variable length advertisement, you wouldn't have to use the former. That's not the case because you still should set it for the existing flags for backward compatibility because it's part of the prefix in both cases, for both 7684 and the OSPF v3 one, 8362 or whatever it is. The prefix options in the case of OSPF v3 and the flags field in the case of OSPF v2 extended prefix. It's part of the same field that has the address, so you really have to. So you can't not use it.
Yeah, my comment is actually the same. I think this maybe we need to go over this on the list, but when I read the the sort of transition that last slide talked about, to me it sounded wrong. At least when I read the document, it was like preferring like the new advertisement over the old one is almost always wrong, right? Because the non-implementers or people who don't understand it are picking something different. But I could have misread it. Either case, I think that needs some review on the list.
I think, and it actually said you could omit it. You can't omit it because the flag is there. You might as well set it correctly.
Yeah.
And have that in the draft.
Yeah. Unless, okay. So anyway, more on the list on that, I think.
Mm-hmm.
Okay. Thank you.
Thank you.
And more on exactly what the use case is for having other routers know this is an Anycast address.
Okay.
You can answer that on the list too. What the use case is.
All right, you're up and you're ready. Here's the slides. I shouldn't be in the queue. All right, you're up.
Hello?
Yes, we can hear you.
Yeah, okay. Okay. Thanks for giving me the opportunity. My topic is easy extensions for link bit error ratio. As we know, in certain networks, network performance criteria are becoming as critical as other metrics to data plan selection. And this draft describes the extensions to easy traffic engineering metric extensions. This draft provides the necessary easy extensions about the link bit error ratio that may need to be used to describe network performance. As other is these T metric extensions, for example, the unidirectional link loss and the unidirectional link delay. The unidirectional link bit error ratio is also meant to be used as part of the operation of the routing protocol to enhance CSPF or for other uses, such as supplementing the data used by the controller to compute the policy path. As shown in this diagram, the number first path is the normal IGP path, which has the shortest metric. And we may notify the link bit error ratio of every link by the router to the controller using BPRS. And the controller will calculate a policy path which has a lower link bit error ratio, as shown by number 2 path, so that different service may use different paths. And this slide, we define the unidirectional link bit error ratio sub-TLV to carry the link bit error ratio of the interface associated with the link. The link bit error ratio must be the packet bit error from the local neighbor to the remote neighbor. And this sub-TLV is advertised as an optional sub-TLV of neighbor TLV in RSP. The format is shown here. It is similar to unidirectional link loss sub-TLV. The type is to be defined. The length is a constant value, 4. And we define 1 byte flags and only use 1 bit here. We call anomalous bit and A bit. The A bit is set when the measured value exceeds this configured maximum threshold and will be cleared when the value falls below its configured reuse threshold. And we use 3 bytes to carry link bit error ratio. So we have a basic unit as shown here. And so that the maximum value we can advertise is almost 50%. Here we have to assume. We assume that precision is more important on high-speed links than the ability to advertise a greater value than this. And the second is the high-speed links with over 50% bit error are unusable. Yeah, thank you everyone. And I hope to get comments from my list. Thank you. Any question?
Yeah, I have a question. What bit error rate?
Okay.
Is this pre-FEC or post-FEC? Is it before correction or after correction?
I think it is before correction.
Right. So this is hard. I mean, I know what you're going for here is basically link quality, a different measurement of link quality. My experience, the operator I've worked for was Deutsche Telekom, right? So it was way up high in the pecking order, and we worked on a new network. And for us, any post-FEC bit error rate meant you took the thing out of service. There was no percentage. Any pre-FEC bit error rate, unless it was immediately spiking, just meant the thing was working, right? I mean, if you have a 0 bit error rate post-FEC, you have no packet loss due to bit errors. right? And if you do have a post-fact bit error rate, then at least the operator I work for, you just stop using that link altogether. Now, there on all the routers, there's alarms and different things that can watch this stuff. I'm just not sure how useful this is. I'm interested in hearing from other people and other, specifically, either other operators at the, sort of default free, but also, maybe does this have some kind of application in lossier networks? I don't know, but I'm worried that this is too fine of a grain to be looking at on the routing level.
Yeah, I'll just come in there. Speaking as working group member, I see the encoding looks fine. I mean, it's similar to the other extended TE metrics that we spent a lot of time on years ago. But I'm wondering what bit error rate offers you over and above packet loss. They seem like they're, basically both at a high level metrics of, the link quality. And really, it seems like what's delivered, the packet loss, is a more important metric than the lower level at the, at layer 1, the bit error rate, the physical layer. So I don't really see the advantage of it. And would like to hear from other operators.
Yeah, Randy agreed with me in the chat that if you see post-fact bit errors, you just take it out of service. Yeah. So this is all just echoing the same thing, right? And then AC is saying the same thing. We'll take it to the list, but this may not be that useful. We'll see. Too much information, right?
So the question now is, do we want to try and load Ajun's stub link or advertisement presentation quickly or not?
Yeah, I don't know. We only have 2 minutes, but yeah, why not? Let's do it.
Okay.
My dog's waiting for me to take her for a walk. You can see her in the background.
Sure.
I can't see the screen.
Yes.
Yes.
No, but I cannot see the screen.
Oh, okay. I'll stop.
Okay, yeah. So let's. So this is the advertise of the stub link attribute. So there are many situations. The stub interface are used commonly in network, but currently there is no suitable place to advertise the stub interface and their associated attributes. And we also investigated the existing possible solution, and there is no currently there is no suitable place. So we think it is necessary to extend the OSPF and the IS protocol to transfer the stub link and their related attributes. And the update content for the current draft is based on the discussion on the main list. We found the inter-AS TE LSA in OSPF and the inter-AS reachability TLV in IS is a suitable place to contain such information. So we define the sublink TLV and the sub TLV to carry the associated attribute within the OSPF and the ISS. And we also define the link type for the sublink because there are various types of the sublink. So we need to further distinguish them. And the other existing sub-TLV for the link attribute can be reused. And we also discuss the other TLV. That is, there is a link TLV defined in RFC 3630. And we also investigate whether this TLV can be used or not. And we think the such link sub TLV should be mainly used for the link within the ITP protocol, but the sublink is not in the ITP protocol. And if we use such a sub-TLV, the link type within such TLV should also be extended. And there is no sub-TLV to describe the prefix that associated with the sublink. So based on this consideration, we think it is fine to define one new TLV, similar TLV, to contain the information for the sublink. Okay, this is the update, the content and the update of this draft. I think it's also discussed on the mainly intensely on the main list. We also ask for the working group to adopt. Okay, so thank you.
Yeah, Linda, go ahead.
This draft seems like we can use that for distribute the aggregate cost as well. So I'm curious, what's the stub link? How's that different from like a prefix LSA? Is the stub link is always for prefix?
No. I think the stub link can be used to connect many prefixes. You know, for example, in your use case for the 5G edge compute, I think the sublink is a link that's located on the boundary of the 1S. So
yeah, that's the interesting case. We're out of time. I don't know whether it's appropriate or not to run over. I think virtual we can run over a little bit, but it's a little bit better than when you're in person.
It will not be cut automatically. So if we have time, we can discuss it continuously.
Yeah. I mean, I would encourage people to talk about this on the list. This is another one where I don't think we're going to do an adoption call right now because, you know, I think there's still some question as to whether it's needed. I know as a contributor, I don't see why it's needed, but, you know, that's just me as a contributor. But I'd like to see some more discussion on the list about this. Particularly if people have ideas about how to identify stub links without a TLV, right? Because I think that could be done. So then we wouldn't need this. But anyway, more on the list, and I think that's it for presentations.
Yeah, I'm just going to add. I think the encoding now and where it is as a T, you know, for its original purpose was for inter ASTE. It's in the right place and the encoding is fine. The question from my standpoint now is whether people think this additional link type and information is useful for TE.
We have invested. Yeah, we have
other people than the authors. People other than the authors think information is useful. That's what I think we need to find.
Okay, great. Thanks, everybody. Any other comments? We do have this virtual time, so then we'll want to throw some tomatoes at us, or
hopefully we'll be meeting in Europe. I know they're hoping in March. I think that would be that'd be really good if we could meet face to face and have, you know, impromptu side meetings and all the things we're missing.
Yep. Okay.
Okay.
Thank you.
Thanks, everyone. I think it was a good meeting.
Everybody.
Yeah, thank you.
You know, actually, how much time do they give us? Because, you know, usually we hang around at the table a few minutes, right? Like, is that, maybe we should use our overtime for that kind of, they want us to go to gather, I think, right?
I think I got another plan.
It's recorded here, so.
Yeah.
It's not recorded at the end of the session when you're just gathered around the chair table. John says running over is not ideal. I agree. That's
Okay.
always been my thought, is that people need to plan, and it disadvantages people that have other things to do. All right, everybody. Thanks. Bye.
Thanks.